So I'm going to show you the mechanical room right now in the basement.
I'm sorry, it's a little messy. Come downstairs.
It's a true home.
I don't know if the camera is picking this up, but those are LED lights.
And very stylish too.
Here we are in the mechanical room, so I'll start with over here. Not that exciting to see, but what it does is great. This is the air handler for air source heat pump. So for all of our heating and cooling needs for the house, we have two compressors outdoors that basically work the same way a refrigerator works. They either take heat from the air or put heat into the air to make a refrigerant either hot or cold depending on the season. So let's say it's winter and you want to make it hot. So they take thermal energy from the air, heat up the refrigerant, send the refrigerant indoors, and then the refrigerant goes over coils and makes warm air, which is circulated to this zone of the house. And it's a very efficient process. It's the metric that you measure the efficiency, or one of the metrics, is coefficient of performance, and it's comparing to just plain old electric resistance heating. And so the nominal performance of this system is about 3.5, which means that you get 3.5 times the amount of heat for every unit of energy compared to electric resistance. So it's 3.5 times as efficient. And another type of system people might be familiar with is geothermal, which is a ground source heat pump, which works on almost exactly the same principles, except instead of taking the heat from the air, it takes heat from the ground. And geothermal systems are even more efficient because the heat in the ground, the temperature of the ground is much more consistent, but there's a much higher installation cost because you have to dig into the ground, and so you have to balance the initial installation cost and some additional energy you need to use for pumping versus the efficiency gain. In our case, we try to minimize the demand of the house so much that the additional efficiency of a ground source system wasn't really needed, and we got the lower installation cost of an air source heat pump.
So have you thought about using a more traditional heating and cooling system?
So we did look into lots of different options, and there were a number of factors. One is we wanted to get the most efficient system possible. And so, like I was saying, this system is extremely efficient and tends to be more efficient than other comparable systems. Also, we want to minimize our carbon footprint. And so we didn't want to use fossil fuel, and actually it turns out that gas isn't even available on our street, so that wasn't even an option if we wanted it.